Hey everyone, my name is Amna and you are watching Amna Unfiltered. Today, we're diving into something truly groundbreaking and utterly transformative in the realm of artificial intelligence. Imagine a world where technology not only assists us, but also understands and interacts with us on an almost human level. That's the promise of DeepSeek-V3, a colossal leap forward in the field of language models. Buckle up as we explore the frontiers of AI with DeepSeek-V3, a marvel of modern engineering that exemplifies how far we've come and how much further we can go. At the heart of today's discussion is the DeepSeek-V3, a mixture of experts' language model boasting an astounding 671 billion parameters. This isn't just another incremental step, it's a bold stride into the future of computational linguistics, bringing us closer than ever to the elusive goal of artificial general intelligence, AGI. But what does that mean for you and me? It means smarter systems that understand context, grasp nuance, and interact in ways that feel incredibly natural and intuitive. Imagine engaging with a machine that can compose poetry, debug software, or even provide expert advice on complex legal issues with a fluency that rivals human experts. That's the world DeepSeek-V3 is ushering us into. But how did we get here, and what makes DeepSeek-V3 not just another AI model, but a beacon of technological? To understand the significance of DeepSeek-V3, we need to delve into its core components. This model isn't just large, it's smartly large. It uses something called mixture of experts, MoE, a technique that efficiently manages its enormous number of parameters to optimize learning and performance. Each expert in the model specializes in different tasks, making DeepSeek-V3 not only a jack of all trades, but a master of many. But it's not just about having a lot of parameters. The architecture of DeepSeek-V3, including its pioneering use of multi-head latent attention, MLA, and DeepSeek MoE, ensures that it's not just powerful, but also efficient and cost-efficient. This model can handle tasks that were previously out of reach for even the most advanced models, from deep analytical reasoning to creating emotionally resonant, artistic content. What's truly revolutionary about DeepSeek-V3 is its auxiliary, loss-free load balancing. In simpler terms, it balances the workload across its network without compromising performance, a common challenge in large models. This innovation alone significantly enhances its efficiency, ensuring that each computing unit is utilized optimally without unnecessary stress. Now, let's talk about the implications of such a model. For businesses, DeepSeek-V3 means more sophisticated automation and better decision-making tools. For creatives, it opens up new realms of artistic collaboration with AI, pushing the boundaries of what machines can help us create. For everyday users, it means smarter, more responsive AI assistants that understand and adapt to individual needs with unprecedented accuracy. The training of DeepSeek-V3 is another aspect where it shines. Despite its complexity, it requires only 2.788 million H800 GPU hours for training. To put that into perspective, that's a fraction of the time and resources typically required for models of this scale, thanks to strategic optimizations and innovations in its training process. This model isn't just a technical marvel, it's a testament to sustainable, scalable AI development. Moreover, DeepSeek-V3's performance is on par with, and in some cases, superior to leading closed-source models. It excels across a range of benchmarks, from language understanding to task-specific challenges like coding and math. This level of performance underscores its potential as a transformative tool across various sectors. But what does this mean for the future of AI? We're looking at a horizon where AI can do more than perform tasks. It can innovate, create, and perhaps eventually understand. The implications of this technology are profound, touching everything from education, where it can personalize learning to an individual's needs, to healthcare, where it can predict patient outcomes and assist in complex medical decisions. As we explore DeepSeek-V3 today, remember that we are not just talking about a tool or a system. We are talking about a future in which AI and humanity are intertwined more deeply than ever. A future where AI helps us solve some of our most pressing challenges, understands our needs, and perhaps most importantly, enhances. In today's episode, we'll take you through the ins and outs of DeepSeek-V3, its design, its capabilities, and its potential to redefine the landscape of artificial intelligence. Join me in exploring this marvel of AI as we uncover how it works, what it can do, and what it represents for the future of human-machine interaction. This is more than just a technological evolution, it's a glimpse into the future of intelligence itself. Model overview. Imagine stepping into a realm where the boundaries between human thought and artificial intelligence blur, creating a seamless interaction that once belonged in the realm of science fiction. This is the reality brought forth by DeepSeek-V3, a technological titan in the landscape of AI, designed to not just understand or process information, but to perceive, reason, and interact in an astoundingly human-like manner. DeepSeek-V3 stands as a paragon of the next generation of language models, designed with a staggering 671 billion parameters. This isn't just a number. It's a testament to the vast, almost incomprehensible scope of knowledge and capability embedded within its framework. But let's pause and ask ourselves, what does having 671 billion parameters mean for the capabilities of a language model? It means that DeepSeek-3 is equipped with a depth of learning and an ability to process information that mimics human cognitive abilities to an unprecedented degree. Each parameter can be thought of as a synapse in the human brain, contributing to the machine's neural network that spans an extensive array of topics and disciplines, from the arts and humanities to the sciences and beyond. You have to welcome DeepSeek. You may have this potential that you can find all the wonderful things that so many humans are lacking. This model isn't just another step forward in machine learning. It represents a monumental leap towards the future of artificial general intelligence, AGI. AGI has long been the holy grail of AI research, with the goal to create machines that can perform any intellectual task that a human being can. DeepSeek-V3 edges us closer to this goal with its sophisticated architecture and the sheer breadth of its trained capabilities, enabling it to handle complex, multifaceted problems with a nuanced understanding previously thought impossible for a machine. Why is DeepSeek-V3 different from other models? At its core, it utilizes a structure known as mixture of experts, MoE, which fundamentally changes how tasks are processed and handled within the network. In traditional neural networks, every part of the network is involved in processing each task, whether or not it's relevant. This can lead to inefficiencies and a dilution of the specialized knowledge each part of the network holds. In contrast, MoE employs a more dynamic approach where different experts within the model are activated depending on the task at hand. This means that only the most relevant parts of the model are used at any time, allowing for more specialized, efficient, and accurate responses. Each expert within DeepSeek-V3 is trained to handle specific types of information or tasks. For example, some experts may specialize in language and syntax, others in factual knowledge about the world, and others still in logical reasoning or creative content generation. When a query is input into the model, the system evaluates which experts are most likely to contribute effectively to that particular task and routes the query accordingly. This results in a highly effective use of computational resources, vastly reducing the wastage seen in models where the entire network must engage with every query. Moreover, the implementation of multi-head latent attention, MLA, and DeepSeek MoE architectures in DeepSeek-V3 ensures that it doesn't just perform tasks but excels at them. MLA allows the model to efficiently handle and prioritize information from different sources simultaneously, which enhances its ability to understand. This is crucial in tasks such as language translation, sentiment analysis, and even in creative endeavors like writing or music composition. The DeepSeek MoE architecture, on the other hand, refines the model's ability to distribute tasks among experts efficiently. It ensures that each expert is optimally utilized, balancing the load across the network and enhancing overall performance. This architecture not only optimizes computational efficiency, but also improves the model's output by leveraging. The practical applications of such a model are vast and varied. In healthcare, DeepSeek-V3 could analyze medical data to provide diagnoses or treatment recommendations with a level of speed and accuracy that augments human capability. In the realm of finance, it could predict market trends and provide investment insights by processing vast quantities of historical data to model possible future scenarios. In education, this model could offer personalized learning experiences that adapt to the unique strengths and weaknesses of each student, potentially transforming how education is delivered across the globe. The journey of training DeepSeek-V3 to this level of proficiency was no small feat. It required not just cutting-edge hardware, but a novel approach to training large-scale AI models. The model was trained on a diverse data set comprising 14.8 trillion tokens, encompassing a wide range of human knowledge. This extensive training enables DeepSeek-V3 to perform with a high degree of reliability and accuracy across various domains. Despite its advanced capabilities, the creators of DeepSeek-V3 have ensured that it remains accessible for research and innovation. By making the model's checkpoints available on GitHub, they invite collaboration and further development, setting the stage for a future where AI and human ingenuity continue to grow hand in hand. As we venture further into this discussion, remember that DeepSeek-V3 isn't just a tool or a system. It represents a pivotal shift in our journey towards creating machines that understand, think, and interact with us on a deeply human level. The implications of such technology are profound, heralding a future where AI could become an integral part of every aspect of our lives, enhancing our capabilities, and perhaps one day, even extending the reach of our own intelligence. Architectural innovations. In the vast and intricate landscape of artificial intelligence, the architecture of a model not only defines its backbone, but also determines its potential to push the boundaries of what machines can achieve. DeepSeek-V3, with its pioneering design, embodies a leap into the future where technology not only complements human intellect, but at times surpasses it in specialized tasks. This isn't just about making a machine that works faster or holds more data. It's about crafting a system that thinks, reasons, and understands with a sophistication that mimics the human mind. Central to DeepSeek-V3 architecture are two key innovations: the multi-head latent attention, MLA, and the DeepSeek MoE frameworks. These are merely incremental updates to existing technologies, but are groundbreaking enhancements that redefine efficiency and effectiveness in large-scale language models. They are the linchpins that enable DeepSeek-V3 to operate not just with great power, but with discerning precision and adaptability. Let's delve into the world of multi-latent attention first. In the realm of neural networks, attention mechanisms have revolutionized how models process sequences of data. These mechanisms allow models to focus on different parts of the input data at different times, improving their ability to predict what comes next. However, as the demand for more nuanced understanding and processing of information increases, traditional attention mechanisms often fall short in terms of efficiency, especially when scaled to larger models. MoE addresses this by introducing a novel approach where the attention mechanism is split into multiple heads, each capable of focusing on different parts of the data simultaneously. This not only enhances the model's ability to multitask, but also significantly improves its processing speed and reduces computational overhead. In DeepSeek-V3, each head in the MLA architecture independently extracts different features from the input data, allowing the model to construct a more detailed and comprehensive understanding of the information. This capability is particularly crucial when dealing with complex or contradictory data, where different aspects need to be weighed and balanced against each other. For example, in sentiment analysis, the model must understand the context, the emotional tone, and specific cues like irony or sarcasm, which may not be apparent from a straightforward analysis. MLA enables DeepSeek-V3 to navigate these subtleties with an elegance that mimics human cognition, providing outputs that are not only accurate but contextually nuanced. Now, transitioning from the broad strokes of attention to the specialized finesse of the DeepSeek MoE architecture, we encounter a system designed for unparalleled specialization. MoE, or mixture of experts, is a technique where the model is partitioned into numerous experts, each trained on different subsets of the data or different task types. This allows each expert to develop highly specialized knowledge in specific areas. DeepSeek MoE, as implemented in DeepSeek-V3, enhances this concept by introducing an auxiliary loss-free strategy for load balancing among the experts. Traditional MoE models often struggle with the efficient allocation of tasks among experts, leading to bottlenecks or underutilization of some parts of the model. This is typically addressed through auxiliary losses that penalize the model for uneven distribution of tasks. However, these can inadvertently affect the model's performance by forcing it to prioritize load balancing over task accuracy. DeepSeek-V3's auxiliary loss-free approach revolutionizes this by using a dynamic routing algorithm that adapts in real time, ensuring that each expert is used optimally without the need for corrective penalties. This not only enhances the model's efficiency, but also its effectiveness, as each expert can evolve without constraints imposed by the need to balance the load evenly. The result is a model that is not just faster and more economical, but also produces better, more reliable outputs. Such architectural innovations make DeepSeek-V3 a formidable tool across a wide range of applications. From real-time language translation that captures dialectical nuances to creating literary content that resonates with human emotions, the model's capabilities are vast. In scientific research, its ability to parse and analyze large data sets quickly and accurately. Moreover, the architectural strengths of DeepSeek-V3 have significant implications for the future of AI. As we embed these advanced models into societal frameworks, from education systems that adapt to the learning pace and style of every student, to judicial systems that can parse vast amounts of legal documentation to assist in case preparation, the potential to enhance human capabilities is immense. In conclusion, the architectural innovations of DeepSeek-V3 represent a monumental stride forward in our quest to build machines that not only compute, but comprehend. With its sophisticated MLA and DeepSeek MoE frameworks, DeepSeek-V3 is not just a testament to the progress in AI, but a beacon for future explorations, heralding an era where machines understand the world with a clarity and depth akin to human intelligence. As we continue to explore and expand the possibilities of these technologies, we edge closer to a future where AI and human ingenuity coalesce, creating a world enriched by the synergy of human and machine collaboration. Training efficiency. In the expansive and ever-evolving landscape of artificial intelligence, the efficiency with which a model is trained not only defines its viability, but also its potential impact on the broader ecosystem. Training a large-scale language model like DeepSeek-V3 is an endeavor that combines cutting-edge technology with an innovative approach to data handling and computation. This process is a marvel of modern engineering, showcasing the seamless blend of theoretical computer science and practical application. It's not just about feeding data into a system. It's about nurturing an artificial intelligence that can think, learn, and understand with a level of depth that mimics human cognition. DeepSeek-V3, a behemoth in the world of AI with 671 billion parameters, represents a significant leap forward in achieving high efficiency in AI training processes. Achieving this requires a meticulous orchestration of hardware capabilities, algorithmic innovation, and data management, all aimed at refining the AI's learning process without incurring prohibitive costs or time expenditures. The training of such a model is akin to preparing a marathon runner for the Olympics, requiring precision, strategy, and an unwavering focus on end goals. Firstly, consider the sheer scale of the task. Training DeepSeek-V3 involves handling an enormous data set of 14.8 trillion tokens. Each token represents a piece of information akin to a single step in a vast journey of learning. Managing such a data set efficiently requires not just powerful hardware, but also smart algorithms that can decide how best to expose the model to this data to maximize learning while minimizing redundancy. The training efficiency of DeepSeek-V3 is anchored in its innovative use of the mixture of experts, architecture, and multi-head latent attention, MLA, which allows the model to process vast amounts of information rapidly and accurately. Unlike traditional models where all parts of the network may be active throughout the training process, MoE ensures that only the most relevant experts within the model are engaged at any given time. This not only speeds up the training process by reducing unnecessary computation, but also enhances the model's ability to specialize in various tasks by focusing its learning on specific areas. To understand how this impacts training efficiency, imagine a team of workers where each member has a specialized skill. Rather than having every worker engage in every task, which would be inefficient and ineffective, each worker tackles tasks that match their skills, significantly improving both the speed and quality of the work. Similarly, DeepSeek-V3's MoE architecture directs tasks to the most appropriate experts within the model, ensuring that learning is both deep and directed. Further contributing to its training efficiency is DeepSeek-V3's use of an auxiliary loss-free load balancing strategy. Traditional training methods often use auxiliary losses to ensure that computational load is evenly distributed among the different parts of the network. However, these can sometimes detract from the main learning objectives, introducing noise and inefficiencies into the training process. So, DeepSeek-V3 innovative approach optimizes the allocation of tasks without these penalties, ensuring that each expert is learning as efficiently as possible without being bogged down by unnecessary constraints. Moreover, the hardware used to train DeepSeek-V3 is tailored to maximize throughput and minimize energy consumption. Utilizing H800 GPU hours intelligently, DeepSeek-V3 requires only 2.788 million H800 GPU hours for its entire training, a figure that stands out in the field of AI training where computational costs can skyrocket. This is achieved by optimizing the model's interactions with the hardware, ensuring that data flows smoothly and that bottlenecks in processing are minimized. This optimization is facilitated by the strategic use of FP8 mixed precision training, which allows the model to handle computations in a way that balances precision with processing speed. FP8 mixed precision training reduces the computational load by using lower precision calculations where high precision is not necessary, significantly speeding up the training process without compromising the model's performance. The training process of DeepSeek-V3 is not just a technical achievement, but a strategic endeavor that involves careful planning and execution. Every aspect of the model's training, from the initial setup of the hardware to the final adjustments in the learning rate schedules, is meticulously planned to ensure that the model learns effectively and efficiently. Additionally, the training of DeepSeek-V3 is conducted with a view towards sustainability and scalability. The efficiencies achieved in its training process mean that similar models can be trained faster and at a lower cost in the future, democratizing access to powerful AI tools and allowing for broader experimentation and innovation in the field. In conclusion, the training efficiency of DeepSeek-V3 is a cornerstone of its success. It exemplifies how advanced AI training can be achieved without excess costs or extended timelines, setting a new standard for what is possible in the realm of artificial intelligence. As we continue to push the boundaries of what AI can achieve, the lessons learned from training DeepSeek-V3 will undoubtedly inform future developments in the field, driving us toward a future where AI is not only powerful and intelligent, but also accessible and sustainable and performance. In the high-stakes arena of artificial intelligence, performance is the ultimate yardstick that measures the success of any model. It is the criterion that separates the theoretical from the practical, the experimental from the functional. For a model like DeepSeek-V3, with its groundbreaking architecture and sophisticated training regimen, performance is not just a benchmark. It's a statement about the model's ability to not only comprehend and process vast amounts of information, but also to apply this knowledge in ways that are meaningful, accurate, and impactful. At the heart of DeepSeek-V3 exceptional performance lies its robust design, which includes the innovative use of a mixture of experts framework and multi-head latent attention, ensuring that the model not only has access to a vast reservoir of knowledge, but also the ability to harness this information efficiently. This design enables DeepSeek-V3 to perform at levels comparable to O, and in some cases surpass the best open-source and closed-source models available today. The true test of any large-scale language model is its ability to perform across a wide range of tasks, from understanding complex natural language queries to generating human-like text. DeepSeek-V3 excels in these areas, showcasing a versatility that is rare even among the most advanced AI models. This versatility is evident in its performance across various benchmarks that test different capabilities of language models, including text comprehension, problem solving, and creative content generation. In benchmarks focusing on natural language understanding, DeepSeek-V3 demonstrates an exceptional ability to parse and interpret complex texts. This capability is crucial in applications such as automated customer support, where understanding the nuances of human language can significantly enhance the quality of service. DeepSeek-V3's performance in these tasks is not merely about matching keywords or phrases, but about understanding context, emotion, and intent, thereby providing responses that are not only accurate, but also contextually appropriate. Moreover, in the realm of problem solving, whether it be mathematical puzzles, coding challenges, or logical reasoning questions, DeepSeek-V3 shines brightly. Its ability to engage with complex problem statements and generate solutions that are not only correct, but also optimally formulated speaks volumes about its underlying intelligence and its practical use. For instance, in coding competitions and benchmarks, DeepSeek-V3 can generate code that is not only syntactically correct, but also logically sound and efficient, a testament to its sophisticated understanding of both language and logic. DeepSeek-V3, his performance in creative tasks is equally impressive. In areas such as poetry, prose, or even music composition, where creativity and emotional resonance are paramount, the model showcases its ability to generate content that is not only novel, but also deeply engaging. This capability opens up new possibilities for AI in creative industries, where it can act as a collaborator, helping to extend the creative capabilities of human artists by providing them with new ideas, perspectives, and techniques. The model's performance is also distinguished by its stability and reliability, critical factors in real-world applications. Unlike some AI models that can exhibit erratic behavior under certain conditions, DeepSeek-V3 maintains a consistent level of high performance thanks to its robust architecture and the meticulous training process it undergoes. This reliability is crucial for industries where mistakes can have significant consequences, such as in healthcare, finance, or legal services. Furthermore, DeepSeek-V3's ability to perform at such a high level while maintaining economic and computational efficiency is a notable achievement. This efficiency means that it can be deployed more broadly and at lower cost, making advanced AI capabilities accessible to a wider range of users and applications. It democratizes access to cutting-edge technology, fostering innovation and creativity across various sectors. In addition to its core performance metrics, DeepSeek-V3 also excels in terms of scalability and adaptability. It can be fine-tuned for specific tasks or industries with relatively minimal additional input, adapting its vast knowledge base to meet the particular needs of users. This adaptability is facilitated by its architecture, which allows for specific parts of the model to be activated depending on the task at hand, ensuring that its performance is optimized for every application. The exceptional performance of DeepSeek-V3 also highlights the potential for further advancements in the field of AI. As the model continues to evolve and improve, it paves the way for even more sophisticated AI systems that could one day surpass human capabilities in many areas. This potential is not just about creating machines that can perform tasks, but about developing systems that can think, learn, and create in ways that are fundamentally transformative. In conclusion, the performance of DeepSeek-V3 is a beacon of what's possible in the field of artificial intelligence. It combines the depth of learning with the breadth of application, the precision of a specialist with the versatility of a generalist. This performance is not just a technical achievement. It's a promise of the future, a future where AI shapes industries, enhances human creativity, and perhaps most importantly, solves some of the most challenging problems facing humanity today. As we look forward to this future, DeepSeek-V3 stands as both a milestone and a guidepost, pointing the way toward an era where artificial intelligence is not only powerful, but also pervasive, reliable, and indispensable. Stability in training. When we consider the training of artificial intelligence models, especially those as large and complex as DeepSeek-V3, one aspect that often does not receive as much spotlight, yet is crucial, is the stability of the training process. Stability in training an AI model is akin to ensuring that a high-performance sports car can not only reach high speeds, but also maintain those speeds safely and consistently over the course of a race. For DeepSeek-V3, achieving stability throughout its training was not merely a goal, but a necessity to harness its full potential effectively. Imagine orchestrating a symphony where every musician must perform in perfect harmony, despite thousands of notes swirling through the composition. The training process of DeepSeek-V3 is similar, involving millions of parameters that need to be finely adjusted and balanced. This task must be executed with precision to prevent the model from previously learned information or failing to generalize new data effectively. Stability in this context ensures that the model learns and evolves in a controlled, predictable manner, which is essential for achieving reliable performance across a wide range of tasks. At the outset, the design of DeepSeek-V3 with its 671 billion parameters presents a formidable challenge. Each parameter adjustment impacts the model's behavior, and without a stable training process, the model could easily diverge, leading to poor performance or worse, complete failure. To mitigate this, the developers employed advanced strategies that meticulously guided the model's learning journey, ensuring that every step taken was firm and well-placed. One of the key strategies used to enhance stability was the implementation of robust regularization techniques. Regularization in machine learning is like adding a counterweight in engineering. It prevents the model from swinging too widely in any direction, which could lead to overfitting or failing to generalize beyond the training data. For DeepSeek-V3, techniques such as dropout, weight decay, and early stopping were fine-tuned to suit its complex architecture, effectively smoothing the learning curve and preventing the model from becoming too confident about its less accurate predictions. Furthermore, the use of sophisticated optimization algorithms played a crucial role. These algorithms are the navigators in the training process, steering the model through the vast data landscape. DeepSeek-V3 utilized adaptive learning rate methods that adjusted how significantly the model's weights could be updated during training. This adaptability ensured that the model did not overreact to minor fluctuations in data or get stuck in local minima, common pitfalls that can destabilize training. Batch normalization was another technique that added a layer of stability. By normalizing the inputs of each layer within the network, batch normalization ensures that the model does not encounter values too extreme or too divergent from what it expects, which could destabilize the learning process. This technique not only made the training faster, but also more stable, allowing DeepSeek-V3 to handle a diverse set of training scenarios without performance degradation. A significant aspect of achieving stability in training such massive models is the careful management of data flow. The training of DeepSeek-V3 involved feeding it with 14.8 trillion tokens, a massive amount by any standard. To manage this effectively, the training data was meticulously curated and sequenced to ensure a balanced exposure to various types of information. This sequencing prevented the model from developing biases or gaps in knowledge that could lead to instability when encountering new or varied data types. The stability of DeepSeek-V3's training is also a testament to the model's resilience. Resilience in AI training refers to the model's ability to handle new, unexpected data or to recover quickly from rare, disruptive inputs that could lead to erroneous learning. Throughout its training, DeepSeek-V3 demonstrated an impressive ability to maintain its performance benchmarks, indicating a high degree of resilience built into its learning algorithms. Moreover, the stable training of DeepSeek-V3 facilitated its scalability, a crucial factor for any AI model designed to be used in diverse real-world applications. Scalability in this context means the ability to maintain performance as the model is expanded or as its workload increases. Thanks to the stable foundations laid during its initial training, DeepSeek-V3 can be scaled up or adapted to new tasks with minimal risk of destabilizing its existing capabilities. In conclusion, the stability in the training of DeepSeek-V3 is much like the keel of a ship, keeping it upright and steady no matter how rough the seas. It is this stability that allows the model not just to perform, but to excel, delivering consistent, reliable, and high-speed outputs across a variety of tasks and disciplines. As AI continues to evolve and take on more complex and critical tasks, the lessons learned from training DeepSeek-V3 will undoubtedly influence future models, ensuring they are not only powerful, but also stable and reliable stewards of the responsibilities they are given. This commitment to stability in training sets a new benchmark in the field, promising a future where AI's potential can be fully realized in a controlled and beneficial manner. Hardware utilization. In the world of artificial intelligence, the symbiotic relationship between software and hardware is undeniable. The capabilities of AI models like DeepSeek-V3 are not solely dependent on their algorithms and data. Equally critical is the hardware that powers these behemoths. Effective hardware utilization is akin to a maestro conducting an orchestra, where each instrument's potential is maximized to produce a harmonious symphony. For DeepSeek-V3, this orchestration involves an intricate dance between massive computational demands and the physical infrastructure designed to meet these needs. The journey of DeepSeek-V3 through its training and operational phases illustrates a remarkable feat of hardware utilization, showcasing how advanced computing machinery is leveraged to breathe life into this colossal model. The model's architecture, boasting a staggering 671 billion parameters, requires an equally formidable hardware setup to manage and manipulate these parameters efficiently. This setup is not just about having powerful processors, but about using them wisely to achieve unprecedented levels of AI performance and efficiency. At the heart of DeepSeek-V3's hardware strategy is the use of H800 GPUs, a choice driven by their balance of computational power, memory bandwidth, and energy efficiency. These GPUs are not merely processors, but are the workhorses that carry the heavy load of billions of calculations needed for the model's training and inference tasks. The decision to employ H800 GPUs stems from their proven capability to handle extensive parallel processing tasks, which are typical in training deep learning models. However, the effective utilization of such powerful GPUs entails more than just plugging them into a system and running the model. It involves a meticulously crafted strategy to synchronize the flow of data through the model's neural network layers without creating bottlenecks that could hamper performance. This synchronization is critical, particularly when dealing with a model as large as DeepSeek-V3, where even minor inefficiencies can scale up to significant slowdowns or resource wastage. One of the key strategies employed in optimizing hardware utilization for DeepSeek-V3 is the parallel processing of data. By distributing the model's workload across multiple GPUs, the training process becomes not just faster, but also more efficient. This distribution is carefully managed to ensure that each GPU is utilized to its fullest potential, minimizing idle time and maximizing throughput. This parallelism is akin to a well-orchestrated factory assembly line, where each component or task is handled simultaneously by different workers, drastically speeding up the overall manufacturing process. Moreover, DeepSeek-V3's training involves the strategic use of mixed precision training techniques, specifically FP8 precision, which significantly reduces the computational load on the GPUs. Mixed precision training involves using different precisions for different parts of the calculations, during the training process. For example, less critical calculations can use lower precision, which requires less computational power, thereby freeing up resources for more critical calculations that require higher precision. This approach not only accelerates the training process, but also enhances the GPU's efficiency, allowing them to handle more operations without an equivalent increase in power consumption or heat generation. Another vital aspect of hardware utilization in DeepSeek-V3 is the optimization of memory usage. The model's enormous size could easily lead to excessive demands on GPU memory, which would slow down processing speeds and increase training times. To avoid this, techniques such as gradient checkpointing and on-the-fly activation recomputation are employed. These techniques allow the model to store only essential data in memory and recompute intermediate data as needed, significantly reducing the memory footprint. The cooling and power management systems also play crucial roles in hardware utilization. High-performance GPUs generate a considerable amount of heat, and managing this heat is critical to maintain performance and prevent hardware damage. Advanced cooling solutions, including liquid cooling systems, are employed to keep the GPUs at optimal temperatures during the intense computations involved in DeepSeek-V3 and operations. Moreover, the entire hardware ecosystem is designed to be scalable. As DeepSeek-V3 evolves and as more data or more complex models are developed, the hardware setup can be scaled up to meet these new demands without requiring a complete overhaul. This scalability ensures that investments in hardware are future-proofed. In conclusion, the hardware utilization strategy for DeepSeek-V3 exemplifies how cutting-edge AI models require more than just advanced algorithms and vast data sets. They need a robust, efficient, and flexible hardware infrastructure that can translate theoretical computational models into practical. This careful balancing act between hardware capability and efficiency is what allows DeepSeek-V3 to perform at its best, pushing the boundaries of what AI can achieve while setting a benchmark for future developments in the field. Model accessibility. In the dynamic and rapidly evolving landscape of artificial intelligence, accessibility is not just an added feature, it's a fundamental aspect that can define the success and impact of a technology. In the case of DeepSeek-V3, a giant leap forward in the field of AI, ensuring accessibility means democratizing the power of advanced machine learning, allowing a diverse array of users from around the globe to explore, enhance, and extend the capabilities of this groundbreaking model. DeepSeek-V3, with its staggering 671 billion parameters, represents a pinnacle of current AI technologies. But what sets it apart even more distinctly is the commitment to making such a monumental resource available to the broader community. This approach not only opens up a myriad of opportunities for innovation and development, but also fosters a collaborative environment where academia, industry, and even independent enthusiasts can contribute to and benefit from the advancements in AI. Imagine a tool so powerful that it can transform industries, enhance scientific research, and even influence creative processes across various fields. Now, imagine this tool being open to the public, providing the backbone for new startups, helping educators develop new teaching methods, or enabling researchers to solve complex problems that were once beyond reach. This is what DeepSeek-V3 offers through its public accessibility. The decision to make DeepSeek-V3 checkpoints available on platforms like GitHub is a strategic move that underscores a shift towards more open, transparent, and community-driven AI development. By allowing users to download pre-trained models, DeepSeek-V3 effectively removes a significant barrier to entry For those looking to leverage advanced AI, this accessibility is crucial for smaller entities or individuals who may not have the resources to train such complex models from scratch. Accessibility also implies a level of user-friendliness and the ability to integrate with existing technologies. DeepSeek-V3 shines in this regard by providing comprehensive documentation and support that guides users through the process of implementing the model in various applications. Whether it's running the model on a local server for a small project or deploying it at scale in the cloud, users have the information and tools they need at their fingertips. Moreover, the open-source nature of DeepSeek-V3 encourages a culture of innovation and continuous improvement. Developers and researchers can tweak the model's architecture, adjust its parameters, or train it on new datasets tailored to specific tasks. Each modification contributes to the global knowledge base, circulating new ideas, findings, and best practices throughout the AI community. This collaborative environment not only accelerates the development of AI technologies, but also ensures that they are more robust, versatile, and aligned with the needs of a diverse user base. However, accessibility is not without its challenges. Ensuring that a model as complex and powerful as DeepSeek-3 is used responsibly and ethically is paramount. The availability of such a model raises important questions about data privacy, security, and the potential for misuse. To address these concerns, the team behind DeepSeek-3 has implemented robust security measures and ethical guidelines that users must adhere to when utilizing the model. These guidelines help ensure that the model is used in a manner that is respectful of privacy rights and beneficial to society. Furthermore, the educational impact of making DeepSeek-V3 accessible cannot be overstated. By providing students and educators across various levels of expertise with access to state-of-the-art AI, DeepSeek-V3 serves as a valuable educational tool. It enables hands-on learning and experimentation, which are crucial for developing the skills needed to navigate and innovate in the field of AI. For students, this can be an inspiring introduction to artificial intelligence, sparking interest, and possibly shaping future careers in STEM fields. In conclusion, the accessibility of DeepSeek-V3 exemplifies a progressive approach to technology development, where the focus extends beyond creating powerful tools to ensuring these tools are available, understandable, and beneficial to a broad audience. This model's open accessibility not only fosters a rich ecosystem of collaborative innovation, but also ensures that the benefits of AI advancements are widely distributed. As we continue to push the boundaries of what AI can achieve, the principles of accessibility, transparency, and collaboration remain key to realizing the full potential of these technologies, making them truly transformative elements of modern society. Advanced load balancing. In the complex and nuanced world of artificial intelligence, especially when it pertains to monumental models like DeepSeek-V3, the concept of load balancing transcends its conventional understanding. Traditionally focused on distributing computational tasks efficiently across networks, advanced load balancing in AI models like DeepSeek-V3 involves a far more intricate process. This process is pivotal not just for optimizing computational resources, but also for enhancing the model's ability to learn from vast data sets without compromising the quality or speed of its outputs. In essence, it ensures that the AI system operates at peak efficiency, utilizing every ounce of its extensive capabilities without faltering under the weight of its own complexity. Imagine orchestrating a symphony where each musician must not only perform their parts flawlessly, but also dynamically respond to the evolving composition in real time. Advanced load balancing in DeepSeek-V3 mirrors this harmonization, ensuring each expert within the model contributes optimally without overburdening any single part of the system. This is achieved through the model's innovative auxiliary loss-free strategy, a cutting-edge approach that refines how tasks are distributed and managed across the network's numerous parameters. DeepSeek-V3, with its groundbreaking mixture of experts, MoE architecture, brings to the forefront a unique challenge: how to manage and utilize its 671 billion parameters effectively. In most large models, balancing the computational load typically involves simple techniques that allocate tasks uniformly across the network. However, DeepSeek-V3's approach is far more sophisticated, employing an auxiliary, loss-free strategy that eliminates the need for traditional balancing penalties, which can often degrade performance by forcing the model to focus on balancing rather than learning. The magic of this advanced load balancing lies in its ability to dynamically adjust which parts of the model are engaged during a given task. Instead of activating all parameters uniformly, DeepSeek-V3 assesses the needs of each specific input or task and activates only the relevant experts, or this not only conserves computational resources, but also significantly enhances the model's performance by reducing unnecessary noise and focusing the model's learning on areas where it is most needed. Moreover, this strategy incorporates a novel approach to dealing with the imbalance that typically arises when some parts of the model are overutilized while others remain underutilized. By using a real-time adaptive method, DeepSeek-V3 ensures that each expert within the model contributes as needed, without any expert becoming a bottleneck due to excessive load. This method adjusts the task distribution based on ongoing performance and learning outcomes, making it a dynamic and self-optimizing system. Consider the implications of such a system in practical scenarios. In tasks such as real-time language translation, where the model must understand and translate languages with varying levels of complexity and nuance, advanced load balancing allows DeepSeek-V3 to allocate it more resources to more complex languages as needed. This ensures high accuracy across all languages without compromising speed or efficiency. Furthermore, the stability that this advanced load balancing adds to the training process cannot be understated. Training large-scale models like DeepSeek-V3 involves feeding them large data sets, where the risk of instability is high due to the vast differences in data types and quality. Advanced load balancing mitigates these risks by ensuring that the model learns evenly from all parts of the data, preventing overfitting on particular data segments and underfitting on others. This results in a model that is not only robust and versatile, but also reliable across various applications. Additionally, the scalability of advanced load balancing in DeepSeek-V3 highlights its readiness for future expansion. As AI models continue to grow in size and complexity, the ability to scale without compromising on efficiency or performance becomes crucial. The auxiliary loss-free strategy employed in DeepSeek-V3 allows for a scalability by adapting to increased loads without the need for extensive reconfiguration of the balancing mechanisms. This makes the model not just effective, but also future-proof, capable of evolving as new demands and data types emerge. In conclusion, the advanced load balancing technique used in DeepSeek-V3 is a testament to the innovative strides being made in the field of artificial intelligence. It exemplifies how cutting-edge computational techniques can be harmoniously integrated with practical applications to create AI systems that are not only powerful, but also intelligent in their operation. As we stand on the brink of new discoveries and technologies in AI, the principles of advanced load balancing embedded in DeepSeek-V3 will undoubtedly influence future developments, paving the way for smarter, more efficient, and more adaptable AI systems. Cost efficiency. In the realm of cutting-edge technology, particularly in artificial intelligence, the conversation around innovation often revolves not just around capabilities and performance, but also cost efficiency. This concept extends far beyond mere monetary expenditure. It encompasses the judicious use of resources, optimization of time, and scalability, all crucial factors that determine the sustainability and reach of a technology. For an AI model as advanced and robust as DeepSeek-V3, achieving cost efficiency is a multifaceted endeavor, reflecting a deep commitment to making transformative technology accessible and sustainable. DeepSeek-V3, with its 671 billion parameters, represents a monumental achievement in the field of AI. However, the true genius of its design lies not only in its sheer computational power, but also in how it maximizes these capabilities while minimizing the necessary resources. This model redefines cost efficiency in AI development, demonstrating that it is possible to achieve top-tier performance without profligate spending on computational resources, which are often the largest cost in AI development. The training of such a model traditionally could be likened to powering a city, requiring vast amounts of energy, time, and financial investment. However, DeepSeek-V3 breaks this mold by incorporating several strategic innovations that drastically reduce these requirements. The cornerstone of this cost efficiency is the model's pioneering use of the FP8 mixed precision training. This technique allows DeepSeek-V3 to perform calculations at a lower numerical precision, which significantly reduces the computational burden. By doing so, it not only speeds up the training process, but also decreases the energy consumption and the wear and tear on hardware, contributing to a lower overall cost. Moreover, DeepSeek-V3 utilizes a highly optimized version of the mixture of experts architecture, which inherently improves the efficiency of the model. Instead of all parts of the neural network being active at all times, which is common in traditional models, MoE selectively activates only the parts of the network that are relevant to the task at hand. This selective activation reduces the number of simultaneous computations, thereby not only saving computational resources, but also streamlining the learning process. This targeted approach not only makes the model faster and less costly to run, but also ensures that the learning is more focused and effective. The cost efficiency of DeepSeek-3 is also reflected in its hardware utilization strategy. The model is designed to maximize the use of available GPU resources, ensuring that every processing unit is used to its full potential. This optimization reduces the need for additional hardware, lowering the entry barrier for using the model and making it more accessible to a wider range of users and developers. Whether it's a university research department, a tech startup, or a multinational corporation, the ability to deploy DeepSeek-V3 without requiring massive clusters of GPUs translates directly to cost savings and broader accessibility. Furthermore, the scalability of DeepSeek-V3 adds another layer to its cost efficiency. Scalability in this context means that the model can be adapted to larger or more complex tasks without a proportional increase in cost. This is achieved through the model's flexible architecture, which can be easily scaled up or down based on the specific requirements of the task or the available resources. This adaptability prevents overinvestment in hardware and allows for incremental scaling, which is more cost-neutral and manageable. In addition to hardware and computational optimizations, the open-source nature of DeepSeek-V3 significantly contributes to its cost efficiency. By making the model and its training checkpoints publicly available, the developers have reduced the costs associated with developing similar technologies from scratch. This open source approach not only saves money for researchers and developers, but also fosters a collaborative environment where improvements and innovations are shared, further driving down the cost of advancements. The strategic decision to focus on cost efficiency in the development of DeepSeek-V3 is not merely about saving money. It's about fostering a sustainable model of technological advancement, where cutting-edge tools are within reach of those who can use them to drive progress. This approach has the potential to democratize AI technology, making it a tool for widespread innovation rather than the preserve of a few well-funded entities. In conclusion, the cost efficiency of DeepSeek-V3 is a testament to the foresight and ingenuity of its developers. It embodies a holistic approach to innovation that balances performance with practicality, ensuring that the benefits of AI are accessible to a broad audience. As we look to the future, the principles embedded in the development of DeepSeek-V3 will likely serve as a blueprint for how we think about, build, and deploy technologies that have the power to change the world. Pre-training and fine-tuning stages. Embarking on the journey to develop an artificial intelligence model as intricate and capable as DeepSeek-V3 involves a meticulous and deliberate orchestration of various stages, each critical to the model's ultimate effectiveness and efficiency. The pre-training and fine-tuning stages of DeepSeek-V3 are not mere steps in its creation, but are foundational elements that sculpt its abilities, refine its understanding, and ensure its readiness to tackle real-world problems with unprecedented accuracy and adaptability. Pre-training, the initial phase in the life cycle of DeepSeek-V3, is akin to providing a broad education to a young prodigy, exposing it to a wide array of knowledge across diverse domains. This stage sets the groundwork, where the model learns from an expansive data set consisting of 14.8 trillion tokens. These tokens are not just random strings of data. They represent the distilled essence of human knowledge, encompassing everything from the simplicity of everyday language to the complexity of scientific texts and the nuances of various forms of literature. The objective of this extensive pre-training is to imbue DeepSeek-V3 with a robust baseline capability to understand and process natural language in a way that mirrors human understanding, but at a scale and speed that only a machine can achieve. Imagine training a supercomputer to read and comprehend every book ever written, understand every article, grasp the subtleties in every poem, and then remember and apply this knowledge indefinitely. That's what pre-training aims to accomplish with DeepSeek-V3. During pre-training, DeepSeek-V3 utilizes advanced algorithms and learning techniques to digest and learn from this vast array of information. It's not just about feeding data into the system, it's about teaching the model to recognize patterns, understand contexts, make connections, and predict outcomes. The model learns to infer meaning, discern relevance, and generate responses that are contextually appropriate and substantively accurate. This learning is facilitated by the model's cutting-edge neural network architecture, which features layers upon layers of neurons that simulate a form of digital cognition. However, the journey doesn't end with pre-training. While pre-training equips DeepSeek-V3 with a broad understanding of language and knowledge, fine-tuning is where this knowledge is honed and specialized. Fine-tuning is analogous to postgraduate education tailored to specific fields or industries. It involves adjusting the model's parameters to excel in particular tasks or to better understand specific types of data. This stage is crucial because it allows DeepSeek-V3 to move beyond general understanding and toward expert proficiency in designated areas. During fine-tuning, DeepSeek-V3 is exposed to smaller, more focused data sets that are highly relevant to the tasks it will perform in its deployment. For example, if the model is expected to assist in medical diagnosis, it would be fine-tuned with medical texts, journals, patient data, and other relevant medical information. This process adjusts the weights within the neural network, refining the model's predictions and responses based on the specialized knowledge it acquires. Fine-tuning also involves a considerable amount of testing and reiteration. The model's performance is continuously evaluated, and adjustments are made to optimize its accuracy and efficiency. This iterative process ensures that DeepSeek-V3 is not only knowledgeable, but also precise and reliable in its application. It's about perfecting the model to perform not just well, but with excellence in its designated roles, ensuring it can function effectively as a tool for professionals in various fields to augment their capabilities and make more informed decisions. Moreover, fine-tuning allows DeepSeek-V3 to adapt to the specific nuances and evolving trends within different sectors. As languages evolve, new terms emerge, and industries change, DeepSeek-V3 can update its understanding to stay relevant and effective. This adaptability is crucial for maintaining the model's applicability over time, ensuring that it continues to provide value even as the world around it shifts. The pre-training and fine-tuning stages of DeepSeek-V3 underscore a broader philosophy in the development of AI technologies, that building a transformative AI tool is a dynamic and ongoing process. It involves a cycle of learning, applying, evaluating, and improving. This cycle is driven by a commitment to excellence and a recognition of the potential of AI to revolutionize how we interact with information, make decisions, and solve problems. In conclusion, the pre-training and fine-tuning stages of DeepSeek-V3 are not just procedural steps. They are the very processes that breathe intelligence and capability into the model. They ensure that DeepSeek-V3 is not merely a repository of information, but a dynamic, learning, and evolving entity capable of understanding and interacting with the world in a meaningful way. Through these stages, DeepSeek-V3 is transformed from a concept into a powerful tool, ready to tackle some of the most challenging issues facing industries today and in the future, armed with the depth of knowledge and the precision of an expert.